SQL for Data Analytics Masterclass. Chapter 2. Select, Where, Order by, and Limit. The foundation of 80% of SQL. This chapter teaches you the 4 SQL clauses you'll use almost every day as a data analyst. If you master them, you'll already be able to answer many real business questions. First principles. Imagine you are the CEO of an online shopping company. Your database contains 100 million customers. You ask your data analyst, open quote, show me only customers from Bangalore. Close quote. The analyst doesn't scroll through millions of rows. Instead, they ask the database using SQL. SQL is like giving precise instructions to a super fast assistant. Think of the process like filtering water. Database equals entire water tank. Where equals water filter. Select equals glass you're filling. Order by equals arrange glasses neatly. Limit serve only the first few glasses. Business data set. We'll use this employees table throughout the chapter. Employee ID, name, department, city, salary, age. 1. Ali IT, Bangalore, 829. 2. Sarah, HR, Hyderabad, 55,000, 32. 3. John, Sales, Bangalore, 6,000, 26. 4. Fatima, IT, Delhi, 95,000, 35.5. Ahmed, Finance, 1,000, 31. 6. Priya, HR, Bangalore, 65,000, 28. Part 1. Select, choosing columns. Think of a buffet. You don't eat everything, you pick only what you need. SQL works the same way. You can see the code in our conversation history, meaning, open quote, show only employee names. Close quote. Result, Naili, Sarah, John, Fatima, Ahmed, Priya, multiple columns. You can see the code in our conversation history. Result, salary, Ali, Sarah, 15.5, John, 60, 95,000, Ahmed, 7,000, Priya. Check all columns. You can see the code in our conversation history. Means everything. Interview tip. Avoid select in production unless you genuinely need every column. It transfers more data than necessary and can slow queries. Part 2. Where? Filtering data. Imagine Google. When you search, open quote, Python tutorial, close quote, Google filters billions of pages. Where filters database rows in exactly the same way. Example. You can see the code in our conversation history. Result, name, department, IT, Fatima IT. Numeric comparison. You can see the code in our conversation history. Result, name, salary, Ali, 8,000, Fatima, 95,000. Equal to you can see the code in our conversation history. Not equal. You can see the code in our conversation history dot, or you can see the code in our conversation history. Some databases prefer. It's more portable. Greater than you can see the code in our conversation history. Less than you can see the code in our conversation history. Greater than or equal. You can see the code in our conversation history. Less than or equal. You can see the code in our conversation history. Shut memory trick. Imagine a gatekeeper. Everyone stands in line. Only people matching the rule can enter. Where is that gatekeeper? Part in our conversation history. Result, name, department, IT, Fatima IT. Numeric comparison. You can see the code in our conversation history. Result, name, salary, Ali, 8,000, Fatima, 95,000. Equal to you can see the code in our conversation history. Not equal. You can see the code in our conversation history dot, or you can see the code in our conversation history. Some databases prefer. It's more portable. Greater than you can see the code in our conversation history. Less than you can see the code in our conversation history. Greater than or equal. Code in our conversation history. Less than or equal, you can see the code in our conversation history. Shut memory trick. Imagine a gatekeeper. Everyone stands in line. Only people matching the rule can enter. Where is that gatekeeper? Part SQL for Data Analytics Masterclass. The Analytics Masterclass. Chapter 3. Aggregate Functions. The secret behind every dashboard. Welcome to one of the most important chapters in SQL. If Chapter 2 taught you how to find rows, this chapter teaches you how to summarize data. This is what data analysts do all day. When you open a dashboard in a company, almost every number you see is produced using aggregate functions. Examples: total revenue, 25,000, 84,000, 892,000. Total customers, 8,506,932. Average salary, 72,450. Highest order, 1,075,000. Lowest rating, 1. These numbers come from just 5 aggregate functions. Master these, and you'll understand a large portion of business reporting. First principles. Imagine your teacher has marks for 1,000 students. Instead of reading every mark, the principal asks, what is the average mark? What is the highest mark? What is the lowest mark? How many students appeared? What is the total of all marks? Notice something. The principal doesn't need individual rows. They need one summarized answer. That's exactly what aggregate functions do. Open quote. Many rows, one meaningful value. Close quote. Mental model. Imagine a fruit basket. Instead of looking at every fruit, you ask, total fruits? Average weight? Heaviest fruit? Lightest fruit? Aggregate functions summarize the basket. Our sample table. Employee's ID, name, department, salary, age, department, salary, age. 1. Ali, 8,029. Sarah, 5,000. 3. John, sales, 6 and 26. 4. Fatima, IT, and 35. Ahmed, finance, 731. 6. Priya, HR, 6528. Hack the 5 most important aggregate functions. Think of your hand. 5 fingers, or 5 aggregates. Count sum, avg, min, max. These account for most aggregation you'll perform. 1. Count purpose. Count rows. Imagine counting students in a classroom. Instead of counting manually, 1, 2, 3, SQL counts instantly. You can see the code in our conversation history output. You can see the code in our conversation history. There are 6 employees. Count column. You can see the code in our conversation history. Counts non-null salaries. If one salary is null, it won't be counted. You can see the code in our conversation history. Counts every row, regardless of null values in individual columns. Interview tip: count is generally preferred when you want the total number of rows. Number 2. Sum. Purpose. Add all values. Imagine calculating total monthly sales. You can see the code in our conversation history. Calculation: 80,000 plus 55,000 plus 6,000 plus 95,000, 75,000 equals 40, 25,000. Output. You can see the code in our conversation history. Business example: Amazon manager asks, open quote, how much revenue did we make today? Close quote. You can see the code in our conversation history. That's how total revenue on dashboards is calculated. Number 3. AVG. Purpose. Find the average. Formula: average equals total word count. You can see the code in our conversation history. Calculation: 42 of 1,000 of 6 equals 7,833.33. Output. You can see the code in our conversation history. Real business questions: average salary, average order value, average delivery time, average customer rating, average profit. Analysts use AVG constantly. 4. Min. Purpose. Find the smallest value. You can see the code in our conversation history. Output. You can see the code in our conversation history. Sarah has the minimum salary. Number 5. Max. Purpose. Find the largest value. You can see the code in our conversation history. Output. You can see the code in our conversation history. Fatima has the highest salary. Visual memory trick. Imagine climbing a mountain. You can see the code in our conversation history. Easy to remember. Multiple aggregates together. You can see the code in our conversation history. Output: total employees, total salary, average salary, lowest salary, highest salary. 642,833.33, 55,000, 95,000. This single query gives a mini dashboard. Where with aggregates? Question: how much do IT employees earn in total? You can see the code in our conversation history. Calculation: 80,000, 95,000 equals 175. Question: average salary in HR? You can see the code in our conversation history. Average: 55,000 plus 65,000 for bar 2 equals 60,000. Question: highest salary in finance? You can see the code in our conversation history. Answer: 70,000. Hack null values. Suppose salary 8,000 dot null 60,000. What happens? Sum salary ignores null. AVG salary ignores null. Count salary ignores null. Count SAR still counts all rows. This difference is a favorite interview topic. Count versus count column. Example, salary 8,000. You can see the code in our conversation history. Remember, count SAR counts rows. Count column counts non-null values in that column. Hack, business case study. Imagine you're a data analyst at an e-commerce company. The CEO asks, 1. How many orders today? Count. 2. Total revenue. Sum menu. 3. Average order value. Age order amount. 4. Largest order. Max order amount. 5. Smallest order. Min order amount. Almost every KPI starts this way. Beginner versus expert. Beginner runs separate queries for every metric. Intermediate combines several aggregates in one query. Advanced uses aggregates with group by, filters, joins, and window functions. Expert designs efficient analytical queries that compute dozens of KPIs in a single pass. Common mistakes using count column when you actually need total rows. Forgetting that null values are ignored by most aggregates. Calculating averages manually instead of using AVG. Running multiple queries when one query with several aggregates would do. Mini practice. Using the employees table. 1. Count all employees. 2. Find the total salary paid. 3. Find the average age. 4. Find the highest salary. 5. Find the lowest salary. 6. Count employees whose salary is above 60,000. 7. Find the total salary of HR employees. 8. Find the average salary of employees older than 30. 9. Find the maximum age. 10. Find the minimum age. Half-Fang style interview questions. 1. Explain the difference between count and count column. 2. Why does AVG ignore null values? 3. How would you calculate total revenue for yesterday? 4. How do you find the highest paying customer? 5. Can you use multiple aggregate functions in one query? 6. What happens if all values in a column are null? Memory tricks. 5 fingers equals 5 aggregates. Thumb, count how many? Index, sum, add them. Middle, AVG, middle value conceptually. Ring min, lowest, little, max, highest peak to remember. One-page revision sheet. Aggregate functions. Count all rows. Count column, count non-null values. Sum column, add values. AVG column, average value. Min column, smallest value. Max column, largest value. Key rules. Aggregates summarize many rows into one result. Where filters rows before aggregation. Most aggregates ignore null values. Use aliases, AS, to give meaningful names to results. Have typical business KPIs, number of customers, count, revenue, sum, average order value, AVG lowest price, min, highest sale, max. Action plan. 1. Create a sample table with 20 to 30 rows. 2. Write at least 25 aggregate queries. 3. Combine multiple aggregate functions into one query. 4. Practice filtering with where before aggregating. 5. Make sure you can explain count saw versus count column without notes. What's next? The next chapter is Chapter 4, Group By and Having. This is where SQL becomes truly powerful. You'll learn how to answer questions like revenue by city, average salary by department, top selling products by category, customers who placed more than 10 orders. These are among the most frequently tested SQL topics in data analyst interviews.